An RLC series circuit has a 200 ohm resistor and a 25.0 millihenry inductor. At 8000 Hz, the phase angle is 45.0 degrees. What is the impedance? Alright, we are given an RLC circuit. Let's sketch it. Sketch will look something like this. So we have the source and then we have resistor, inductor, and capacitor in series. What values are given? We are given the resistance R. We are also given the inductance L, 25.0 millihenry. We are given the frequency and also the phase angle. Alright, so now what are we asked to find in A? We are asked to find the impedance. The best way to deal with such a problem is to draw the phasor diagram. There is a phasor diagram. On the vertical, we have the difference between the two reactances. That's inductive reactance and capacitive reactance. And we have on the horizontal the resistance. And the impedance will be the hypotenuse. And the angle is the phase angle here. So what we are required to find is Z. So simply from trigonometry, we know that adjacent divided by the hypotenuse is equal to cosine of the angle. So cos phi is equal to R over Z. Therefore, Z is going to be R over cos phi, basically multiplying both sides by Z and dividing both sides by cos phi. R over cos phi will be the impedance. Just plug in the numbers. Resistance is 200 ohm and the phase is 45 degrees. So 200 ohm divided by cosine of 45.0 degree. Yield is 282.8 ohm. But because we are asked to find the answer in 3 sig.figs, the answer will be 283 ohm. B, find the circuit's capacitance. So we are asked to find the capacitance of the capacitor of the circuit. And this, we still use phasor diagram to find. See, with the help of this, we can find C, the capacitance. It's a two-way process. So let's find the relationship between Z and the resistance and the reactances. Z squared is equal to R squared plus the difference of the reactances squared. So we have, we can subtract R squared from both sides and find the square root of Z squared minus R squared so that we can isolate XL minus XC on one side, everything else on the other side. So we're looking for the capacitive reactance, because capacitive reactance is directly related, somehow related to the capacitance. So in order to find X sub C, we subtract X sub L from both sides and multiply it by -1, and that yields X sub C is equal to X sub L minus square root of Z squared minus R squared in the radical. And just plug in the numbers. However, we're not given X sub L, but we know X sub L is equal to 2 pi times the frequency times the capacitance. Therefore, we can find X sub L. So first, let's find X sub L. And X sub L is equal to 2 pi times 8000, which is the frequency, multiplied by 25.0 times 10 to the minus 300. And that yields 1256.6. So plug this number in here in this equation. Plugging in the numbers, 1256.6 ohm minus the square root of 282.8 squared, which is Z squared that we calculated in A, minus 200 ohm squared, which is a given value. And that yields 1057 ohm. So now we know the capacitive reactance. What we are required to find is C. But we know X sub C is equal to 1 over 2 pi FC. Therefore, we can multiply both sides by C and divide by X sub C, and we can isolate C. C is on one side, 1 over 2 pi F X sub C. We know F and we know X sub C now. We have already calculated X sub C earlier. So just plug in the numbers. 1 over 2 pi times 8,000 times 1,057 ohm yields 1.88 times 10 to the minus 8 farad. So the capacitance of the circuit is 1.88 times 10 to the minus 8 farad. C, if Vrms is equal to 408 volts, this voltage is applied to the circuit, what is the average power of this supplied? What average voltage, power is supplied? So we are given Vrms. We are asked to find the average power. And we know the average power is equal to Vrms squared divided by Z. Just plug in the numbers. So the power will be 480 volts, which is the RMS value squared, divided by 282.8 ohm, which is the Z that we calculated in A. That yields 589 watt. Thank you for watching.